So the quiz, there were 3 questions. One was to evaluate, and the whole quiz was testing your difference of squares formula. Which is whichever way you like it to be. Okay? So the first question was just to evaluate 16 squared minus 6 squared. So what do we notice there as far as that formula goes? Yeah, because it looks like that. We have 2 squares with a minus in between. So yeah, it is 16 minus 6, 16 plus 6, right? Now, can we actually compute that? Can we take that further? What is 16 minus 6? And what is 16 plus 6? And again, multiplying by 10 is easy. What do we get? 2. Right? Okay. So the other 2 questions, I don't remember exactly, but this one was to perform this computation using the difference of squares formula, right? It actually said on every problem. So that's just matching it with the formula. It's x squared minus 4 squared, which is x squared minus 16. Here we go. Is that right? We don't have anything? Oh, this is a big class. Is that all right? And the last question was to factor using the difference of squares formula. So again, you realize that you have a perfect square in the first place, and you have a perfect square in the second place. So you have x being squared here, and what is being squared in the second place? 3. So then formula does the rest. X minus 3, x plus 3. And that's it. That's our quiz. Any questions from that? Good? All right, so that's our first formula. I promised you about 7 of them. So right now we have 1, the difference of squares. And again, I'll just put it here. And again, as I said it last week, it doesn't matter whether you have plus first, minus second. As long as one is a positive, that one is negative. And then you put. Now, the second formula that we'll talk about is called square of a sum. So if you try to translate, this is the hardest part, translating the spoken word into math language. How would you express this square of a sum as an algebraic expression of sorts? What do you do here? Squaring a sum, right? So how many squares do you have? 1. So you have a sum of 2 items, please, and then you're squaring. So let's say it will sound like that. Square of a sum. Okay? Well, again, we can always do this by FOIL. Because square means multiplies by itself. So we can always think of this as a plus b times a plus b. And then we'll do the FOIL. So it's a times a, that's a squared. A times B, that's AB. B times A, I can say that's another AB for the sake of combining like terms later. And B times B, that's B squared. So when we combine like terms, we get A squared plus 2AB plus B squared.
So you only have to have one of them as a minus, and the difference of squares, the square of a sum, can be positive or negative.
Yeah, and we'll do the next one will be square root of the difference. So we'll do. But yeah, good point there. I'll bring it up how we will not have a formula for the sum of squares. It just doesn't really work out as nicely, and I'll bring it up a little later. But yes, you're right. That's why we have an odd number of formulas. Remember I said 7? So everything will go plus minus, plus minus, plus minus, but the difference of squares is the only negative one. So anyway, so here it is. So here's the formula. So it really comes from foiling. Let me erase this little abbreviation. There is another cute way of deriving this formula. You don't have to write this down, but it's using geometry. And I don't remember whether I brought it up in this class. I know I've brought it up in other classes, but when I ask you to say, let's say this term right here out loud, how do you say that?
A squared.
A squared. So we say squared. Why is that squared? Why do you say squared? Second power. So how do we go from a second power to all of a sudden squared? Why is it not tabled? So what's the connection between 2 and saying it's squared all of a sudden?
All the sides are even.
So yeah, so right away you start thinking about the shape, square. That's why we say, A cubed, that connects to the volume of a cube. So there's a connection between these algebraic expressions in geometry. So when I think of A squared, I really think about the area of a square where each side is of length A. That's where the language comes from. So I can actually do that. I can draw a little square. This side is A, and that side is A. So the area of this square is A squared. Okay? I can also draw a little rectangle. And I'm going to place that rectangle right here. A little rectangle where one side is A, so it matches the side of a square, and the other side is B. Well, what is the area of this rectangle? So, well, not square, it's just A times B, right? So it's AB. And I'll do another rectangle, same rectangle, and I'll put it here. So again, this side is A, that side is B. So what is the area of that rectangle? AB. And now look at that little piece. What is that? Yeah, it's a little b, so that's a b squared. Okay? Well, overall, this big shape it's still a square, right? What is the length of one big side? A plus b, right? You're adding them. And the area and the length of that side? So therefore, the area of the entire big square is A plus B squared, right? So we see the area of a big square is A plus B squared. But it can also be broken into pieces. It's A squared plus 2ABs plus B squared. You see that? Using geometry, you have A squared, 2ABs, and a B squared. So it's kind of a cute way of thinking about that same formula. That you can break it down into pieces, interpret that as the area of simple shapes. The reason why I'm bringing this up, well, there'll be a little rule later this semester closer to the end of the semester, and I'll be drawing pictures like that again. But that's cute, isn't it? Yeah, you know, I know you were happy with just me foiling this thing, and it just worked out just fine. But it's just another way to justify that one. That's about it. So here's one, and I'll give you the other one right away. The square of a difference formula. I don't know, that word didn't come out. So it is a minus b squared. Now I can also just do the FOIL here, right? I'll just write a minus b times a minus b, and you'll see what will happen if I just write a minus b times a minus b, and I start FOILing. A times a is a squared. A times negative b is negative ab. Negative b times a is another negative ab. And negative b times negative b gives me what?
Negative b squared.
But it's a negative b times negative, so it's positive b squared. So really, after you combine like terms, the only difference between the sum formula and the difference formula is the sign in front of the two. So you have a plus inside the parenthesis, you get pluses all the way through. If you have a minus inside the parenthesis, you just get a minus in front of the two. The rest of them. Okay? So these are the three formulas that you will owe me. Remember the deal from last week? You have to know these three formulas, and I'll be giving you the other ones, the other four, much more complex. Okay? We made a deal, right? Because I'll unexpectedly test you on that deal one day, and if you don't fall through on your end, then I might not fall through on my end. So make sure you just know these three little formulas. That's really all you have to memorize this whole semester. Those three formulas. The rest will be just development of skills. This is the only memorization. All right, so let's do a whole bunch of examples. So here are our three formulas. So square the sum of 8x and 3. So first I have to translate that into math speak. So that's just squaring the sum of 8x plus and 3, so that's 8x plus 3, and I'm squaring it. Okay? So now we have to decide which formula to use. So I have really three options, so which one do you think we're going to use? Yeah, that's what we see, right? We have two things with the plus, with the square. Now let me copy that formula here. We'll use it. So when you match this expression, 8x plus 3 squared with a plus b squared, what is playing the role of a over here? 8x, right? So the formula tells me take whatever a is and square that. So I'm just going to write that 8x quantity squared. And again, just like from last week, you have to make sure you square in the entire term, whatever the coefficients are. Okay. Then it tells me what? Put a plus. So I'm going to put a plus. And then it tells me put a 2. So I'm going to put a 2. Right? There's always that 2 in there. And then it tells me 2 times a. 8 is 8x in this case. But it's 2ab. What is b? 3. So 2 8x times 3, and then plus whatever b is So that's just the initial setup. I just put the proper quantities for A's and B's. And this is really the hardest part, to put it all together. The rest is easy, you just compute it. But does that make sense how I placed 8 x's? So 8x went for every A, and 3 went for every B, and 2 is just part of the formula, it's always there. Now I'm just going to compute that. So 8x squared is 64x squared, right? 2 times 8 times 3 is what? 48x, and 3 squared is 9. And that's it. How's that? Good? Good. You'll eventually be able to skip that middle step and just go straight for the answer, because you can do this in your head. What you ask to do is to take the first term and square that. Oh, God, it's still you, another chair.
Show you a chair.
Yeah. How many students do we have? Don't we have 28 students today? There's some under the stairs. Ah, that's it. Is anybody still waitlisted? Anyways, so look how I'm thinking about this problem. And eventually you'll get to that point, because you want to do those fast. Take the first term, square that. So that's 64x squared. The hardest part is to get the middle term. And the way I get the middle term, I'm just going to multiply these two things. 8x times 3, that's 24x. And then just double it. You always do the double. Because of that 2. 2 is the part of the formula. That middle term, I call that middle term double product. You multiply two things inside the parentheses, and then you double. So 8x times 3 is 24x, double that, 48. And then the last term squared. Is that okay? Can you see that?
Kinda.
You want to maneuver?
No,
Yeah, because I don't think that's the right angle for you guys. I'm blocking everything in there, right? Well, just come sit over there. Grab that big desk if you want to. Because I know I like to stand on this corner for some reason. And then I know it's just that part of the class. Is that good? Okay, so again, if you're still kind of struggling with it, you can always FOIL. I just don't want to see you FOIL. FOIL on a little piece of paper and then just lie to me. Hey, I just got the answer. The worst thing you can do is just square first plus square second. Just go 64x squared plus 9. That's the worst thing you can do. That means I don't know what that means. That means you don't understand how to square things. But, because you always get that middle thing. All right, let's try another one. Square the difference of, what do I have here, 10x and 7y. So again, in math speak, it's 10x minus 7y quantity squared. Because it says only one square, right? Square the difference. So 10x minus 7y squared. So we'll use that formula for the difference. Square of the difference. We'll use this little formula here. So it's same as the one before, only it has a minus in front of the 2. So that's the only difference between the two formulas. So what's going to be our A? 10x, and what's our B? 7y. So I can just go ahead and shout into that formula. For every A, I put 10x for every b, I put 7y. So if I write it out, it's 10x squared minus 2 times 10x times 7y plus 7y squared. So this is that intermediate step. Again, we'll be able to think straight to the end. So I had a student who, what did she call that step? I don't remember, that was funny. Scribble scrabble, that's the step. Yeah.
Now you have 10x minus 7y, but you didn't put minus 7y.
Right, so that's already taken care of here.
Okay.
Okay, so that negative takes care of the 7y. If I wanted to put 7y here, I mean negative 7y, that would keep that as a plus, and that negative will eventually make its way up
What
front.
about the other one you didn't put?
Oh, it just dies a painful death because it gets squared here, right? So that's always positive. So this is the only negative that survives. Because technically, I mean, I see what you're saying. Technically, this formula is kind of redundant. We don't need a negative formula. We just need a positive formula and just keep the negative if it happens to be negative. So then it just only appears there. But that formula already takes care of the negative, so yeah.
Would that be the same as like 10x plus 7y and then 10x minus 7y, or is that different?
No, that's different. Because again, the square means you're multiplying it by itself.
Okay.
So it's 10x minus 7y times 10x minus 7y.
Okay.
That's what squared is. When you have different terms, then it's not a square, right? Any other questions? Are we okay how we got here? So then just compute 10x squared is 100 x squared. And then what's in the middle? Yeah, negative 140 xy, and then plus 49 y squared. Is that all right? And again, we can think of these problems in one step. You can just go, all right, take the first term, square that, you get yourself 100x squared. Okay. Negative in there means negative in here. And then you do the double product. So you multiply 10 and 7, so that's 70. And then you double that, that's 140. And the variables get tagged along, so 140x squared. And then the last term squared is 49y squared. How's that? Does that make sense? Good. Are you sure? All right. Let's try another example. How about 3x squared minus 4x cubed squared? We're going to review some of our order of operations here. So actually in this case, it'll be a little harder to just go in one move. Let's write it out. Because of the minus, we're going to use the square of the difference formula. But again, we're going to take the first term and we'll square that. So that's, okay, that came out weird. So that's 3x squared, quantity squared. So that's a squared. Minus 2. 2 is always part of the formula. First term, which is 3x squared. Second term, 4x cubed. And again, I don't need to carry the negative anymore. I already took care of the negative. And then plus 4x cubed quantity squared. So again, the way I'm seeing this is a minus b squared. And this is little a squared. This is 2ab b squared. So those are the matches. So 3x squared is the a, and 4x cubed is the b. All right, well now let's compute that. So first term, 3 squared is 9. What is x squared squared? X to the 4th. Good. Minus. So let's compute the coefficients. 2 times 3 times 4, 24. And now what do you do with exponents? X squared times x cubed. Add them, right. X to the 5th. Good. So when we multiply, we add exponents. When we raise power to the power, we'll multiply exponents. Remember how we kind of talked about that? When you multiply, same base, you add exponents. When you raise power to the power, you multiply exponents, right? So things like this, we multiply exponents in this case. Now in this case, we add exponents. Right, so these are our rules of exponents. So therefore, what is the last term?
16 x to the 6.
Right. 4 squared is 16, x cubed squared, multiply them, gives you x to the 6th. Good. Is that all right? Any questions? Good. Let's try this one. Negative 5a minus 4 squared. So we can go ahead and use the square root of difference formula. The only thing is we have to be very careful. Our first term is negative to begin with, so we just have to make sure that we drag that negative all the way through in this case. Or we can play with it a little bit, because every time you see 2 minuses, you can always factor a negative out, okay? But you have to be very careful, because everything is getting squared as well. So when you factor a negative out, that negative remains under the square. It doesn't go all the way out, because that means you would violate the order of operation. So if you want to factor the negative out, see what happens. You will pull the negative out of 5a and 4, but the square still hangs on top of that whole thing. By the order of operations. Oh,
You have to do that?
but look what happens. Just give me 1 second. Now, what is the square going to do with that minus? Get rid of it. So then the whole thing becomes 5a plus 4 squared. Well, that's a lot easier to do. Right?
Easier just to go with 25 and 16.
Yeah, but
Start it.
when I look at a problem that's negative like that over here, I always just know it's going to be positive anyways.
Sure.
Especially if you're squaring negatives are going to end up being positive.
But it's not the case in the previous problem, right?
Yeah.
Even though you're squaring, there's something negative that still comes out negative somewhere.
But the front problem is negative. The front. Like 3x squared was not negative.
Okay, so, but that's what I was saying originally. If you see those kind of negatives, then make sure you treat this negative 5a as your a in your formula. And then 4 is your b in that formula. And then you carry that negative through. So the negatives will cancel out, but you have to be really careful with your negatives then. Because look what happens. If you do it that way, it is negative 5a squared, right? If you're actually thinking of it, negative 5a is your front a. Then minus 2 times, again, negative 5a times 4. And then plus 4 squared. So you have to be really careful and drag this negative through, which is a little tricky. It's easy to lose that negative sign. It will still come out all positive in the end. 25a squared plus whatever this thing is, what is it, 40? Or do that little sneaky thing. Get rid of the negative first, and then you don't have to worry about it anymore. You can just use the positive formula on that. It gives you the same answer. You see that? So yeah, you can do it both ways, but you have to be really careful and make sure that negative carries through. So you do get the same thing here. So let me talk a little bit more about this factoring thing. Because again, the order of operation, in order for me to pull that negative all the way outside, that square blocks it from going all the way outside. In order for me to take it outside, I need to square it first, and that's what happens here. That's why there's no more negative. It got squared it away, or thing like that, and then just became all positive. Is that all right?
What happened to our minus in the middle?
Which one? Which one are you talking about? Because I have two solutions here. Top blue or green?
Well, isn't the bottom solution supposed to have a minus in the middle? Or we're doing, no, we're not doing difference, square of difference, we're doing square of sum.
But again, we're talking blue or green? Tell me.
Blue.
Blue. Okay, so let's see what happened in blue. And I'll talk about green again. So the blue original problem had minus and a minus, right? So we're a little bit stuck here because we haven't seen two minuses before. So what I was suggesting is, when you have two minuses, we'll factor it out. I pulled that minus outside, kept, see, and then that square, and this is the important part, that square made that minus into a plus. So that's why my next step doesn't even have any negative. Yeah? So it's perfectly okay to do that.
So I was just looking, so the power from the outside, since we make that a positive, then that power drops back into the next layer.
Sure, because really what this step is, when I see that negative, I really think of this as negative 1 times 5a plus 4 squared like that. And by the rules of exponents, when I'm taking a product, raise it to the power, it's really raising both parts of that product to the power. So that just becomes positive. So that's what kills that.
So when we're doing a negative, are we doing square of the sum formula?
Well, that's what it ended up to be, because that negative just kind of got cleared it away.
Always. Negative is in square of sum formula.
If everything is squared, sure, we can say always. Yeah, you can just say negative a minus b squared is the same as a plus b squared. That's always going to be the case. Because of that. Because I can factor the negative and then it turns positive. Is that all right? That's a little sneaky. Question?
No.
Any other questions? How was the green part? Did the green part make sense? Make sense or whatever? So the green part, you have to be really careful to drag that negative around. And it just went away, because here it got squared, so that's gone. Here we have a minus and a minus, so that's a plus. So we ended up with the same solution. Is that all right? Good. Let's try this one. So this is just asking you to simplify an expression. So So that's 2x cubed minus y quantity squared. No, that's not what I wanted. Sorry. What I wanted was 2x times 3 plus 8x minus 4x minus 0.5. So I want us to simplify. What that means, open up all the parentheses, combine like terms, see what. So the first term, 2x times the parentheses, all I have to do is to distribute it. There's nothing fancy going on, so 2x times 3 gives me 6x, and 2x times 8x gives you 16x squared. So that's that first parenthesis, so that got cleared away. Now, in the next step, and again, here's the order of operation. What we're doing is we're really multiplying by a minus and we're squaring, right? There are two things going on. So which we do first by the order of operation? Multiply or square? Square. So first I have to do the squaring that difference, and I'll keep that negative in mind. So you kind of saw that last week when we have a negative on the outside, we still keep everything in the parentheses. We'll distribute that negative. But let's do the squaring so we can use our formula. We have a minus in between, so it's just the square of a difference. And the formula tells me square the first, so I'm going to write that. 4x squared minus 2 times the first term, which is 4x, times the second term, which is 0.5, and then plus 0.5 squared. So this is a plus here. Just using our formula, right? Yeah. And I'll take care of that negative sign on the outside on my next step, or whenever I feel like. But is that okay so far? So we kept that negative, made sure we still have a parenthesis, because that negative will finally go in and it will change all the signs. So let's simplify this a little bit. So 4x squared is 16x squared. Now in the middle we have 2 times 4 times 1/2. Right? 2 times 4 times 0.5. What's that? 4. So minus 4x. And 0.5 squared is 0.25. Right? So now we can open up those parentheses, distribute that negative, see what happens. And good things will happen. 6x plus 16x squared. And then distribute the negative, so that gives you negative 16x squared plus 4x minus 0.25. So when we combine like terms, something goes away. 16x squared cancels. We have 6x plus 4x, that's 10x, minus 0.25. So that's it. Yeah.
So, I don't know why, but for the 4x, like when I saw 16
still minus 4x.
Well, because this is what I was saying earlier. That negative sign, it has to multiply the entire term. So that's why I kept it in the parentheses here. So when this negative went in, it turned that negative 4x into a positive 4x. So you have to make sure that that negative sign applies to that entire term. Is that okay? Because again, order of operations, square first and then multiply by a negative. So if you just square and you don't put those parentheses, you really kind of, well, you violated some rules. Is that okay? Okay, good. Try this one on your own. See what you can do. This is not too bad. Just try to run this through a formula. Any luck? Well, there's no luck involved. It's all skill. Anyone? What do we get?
4x to the 6 minus 4x to the third y plus y squared.
Yeah, I like that. And I wrote, you said 6, I wrote 2 because I'm silly. That's 6. You did say 6. Yeah. I just wrote 2. Is that right? Because again, take first term, square that, 4x to the 6, multiply exponents. Then multiply these two things, double that, that's where 4 comes from. And then the variables kind of stay the same. And then the last term is squared. Is that okay?
Isn't the middle y squared also?
Well, but in the middle, we just multiply them, right? This is A, and this is B. Well, B is just Y, right? So when you do 2AB, that's 2 times 2x cubed times Y. So that's how we get that. Let's do something fun. 102 squared. Can you do that one fast in your head?
1044.
No, but could be close.
Close.
1044.
Put a few more zeros somewhere.
No. I think you have plenty of zeros, and you got the last digit, but the one in the middle not solved on yet. But the way you can do this problem, 102 is hard to square. We don't know that in our head. But do we know two numbers that are easy to square and that add up to 102? Well, 102, right? 100 plus 2 is 102. So I can think of this as 100 plus 2 squared. And then I can apply my formula, right? So yeah, you're very close. You have a 4 in the wrong place. But if you use the formula that we just studied, it says take 100, square that. Take 2 times the first term, which is 100, times the next term, which is 2. Right? And then plus 2 squared. So that is 100 squared is 10,000. Plus 2 times 100 times 2 is 400. Plus 4. So if you add them all together, you get 10,404. So you have the 0 in the wrong place, but yes. Is that fun? Sure it is. We use that formula to square larger numbers in our heads. You take a number and you kind of dissect it into two numbers that are easy to square, and then you can do that. We can do that to, let's say, 97 squared. You can think of 97 as 100 minus 3 squared, right? 97 is 100 minus 3. And then you'll do the same thing. You'll go, okay, 100 squared minus 2 times 100 times 3 plus 3 squared. Right? So it is 10,000 minus 600 plus 9. And how much is that? 10,000 minus 600?
1,409.
Yeah. Fun stuff? Good. All right. So that's about all I wanted to share with you today. And now you're going to practice.